Assalamu alaikum wa rahmatullah. Today we are going to discuss and explain the model and die materials, which are gypsum products. Okay, these materials or this subject is the first in the applied dental biomaterials. First of all, you have to understand what is the model and what is the die. The model, as you see in the photograph, it is a positive replica of teeth and associated soft and hard tissues of the jaw, which is obtained by pouring the mix of the gypsum product inside the impression. First of all, you take an impression for your patient, and then you remove it from the patient's mouth, wash it with by water and disinfect it. Then you apply the mix of the gypsum product or the model and die materials inside this impression to obtain a model or form of the jaw of the patient. It is a replica, positive replica of the teeth, okay, and the associated supporting soft and hard tissues of the jaw. Of course, the impression is a negative form and the cast or the model is a positive form. Now, what is the die? The die that you see here in the photograph that take silvery color and is sectioned from the model. This is the die. It is sectioned in order to facilitate its removal from the model. So you can construct or use it for, say, for making the wax pattern over it, for constructing cast restoration. Okay, this is a die. Die is a model or replica of single tooth, only single tooth, and it's associated soft tissues. Okay. Now, what are the ideal requirements of any material to be used for constructing of models or dies? First of all, the mechanical properties. These materials, in order to be used for making model or die, it should be strong enough. Why? In order to resist its breakage during use, during handling the model. If it drops, it should resist the breakage. If it is accidentally dropped, it will resist the breakage. So this depends on its strength. It should have sufficient strength to resist the breakage during use. Number two, hard enough. Why? To resist scratching during carving of wax pattern. As you see in the lower photograph, we have the die, which is a replica of single tooth, and we construct or build a wax pattern over it, and we use a specific sharp metallic instrument in order to carve the wax pattern. Okay, so if this instrument accidentally scratches the die, this will make the wax included inside these scratches, and then the final restoration will have elevations representing this the areas where wax included inside the gypsum or the die. So the final restoration will be inaccurate. So in order to obtain an accurate restoration, the die material itself should be hard enough to resist scratching during carving of wax pattern. In order to obtain a wax pattern, a perfect wax pattern, accurately constructed without any elevations or anything that will affect the accuracy of the final restoration. Okay. Number two, flow before setting. We obtain the gypsum products in the form of powder, and we mix this powder with water to make a slurry, and then we pour this slurry inside the impression. Okay, during pouring the slurry inside the impression, it should have sufficient flow in order to record all the details of the impression. If it is slightly viscous, it will not flow perfectly and will not record all the details of the impression. Okay, so one of the primary requisite for ideal model and die material, it should have flow before setting to reproduce the details or fine details of the impression. Number 3, little dimensional changes during setting. After pouring the mix of model and die material inside the impression, it will undergo setting, it will harden. So during this stage, it should not exhibit any dimensional changes, because this will affect the accuracy of the model. And this also important during storage. After setting or hardening of the model and before using it, sometimes you have to make something before using the die or the model. So during this storage time, the model should not exhibit any dimensional changes. It should be dimensionally stable in order to preserve its accuracy, its accurate surface. Okay. Number 5, compatibility with impression materials. All gypsum products or model and die, model and die materials that we use should be compatible with impression materials. What does it mean, compatible with impression materials? It means that they will not interact with each other. No reaction occur between the model and die material, between the model and the impression material. Okay, to preserve the accuracy of the surface of the model. Okay, no chemical reaction. If there is reaction occurring between the two materials, they are said to be non-compatible. Okay, so the material should be compatible with impression materials. Number 6, good color contrast with impression materials being used. This facilitate easily distinguishing the two materials from each other, and you can separate them. Number 7, of course, ease of use, okay, and cheap. Of course, no material can fulfill all the requirements that have been mentioned, but gypsum products fulfill most of these requirements, so we can use them by overlooking their flaws. Okay. Now the story of gypsum products themselves starts by gypsum. Obtaining gypsum. Gypsum is found in nature in compact mass. It is chemically calcium sulfate dihydrate. Calcium sulfate combined with 2 molecules of water. Okay. By obtaining this compact mass of gypsum and crushing them, then we can treat or manufacture the gypsum products by different ways to obtain 3 different types of products, which are model plaster, dental stone, and high strength stone. All of these products have the same chemical composition. They are all calcium sulfate hemihydrate, only half molecule of water. Okay, all of them have the same chemical composition, but of course they differ in their use. Okay, now you may ask yourself how can we convert calcium sulfate dihydrate to calcium sulfate hemihydrate? This could be done by removing 1.5 molecule of water from each molecule of calcium sulfate dihydrate. This can be done, of course, by heating. Okay. Now you may ask yourselves another question: why do they differ in their use despite of having the same chemical composition? Of course, this is related to the method of manufacturing. The method of heating the gypsum in order to obtain the product, which is calcium sulfate hemihydrate, is different according to the type. Okay, by using different methods of manufacturing, the properties of the powder particles of each type is different. So their use, of course, will be different. Okay. As I have been mentioned, the method of manufacturing of different types of gypsum products is different. So this will lead to difference in the powder particles in each type, specifically the particles size, shape, and their porosity. Okay, so the amount of water required to wet these particles will be different. Okay, the water powder ratio will be different, and hence the properties of the powder or the properties of the model or dye, the result will be different, and so the use will be different. Okay. You see this hand drawing. You see large particles and smaller particles. As you see, if we use large particles, the amount of water required to wet these particles is less than the amount of water used in wetting smaller powder particles. The same in regular and irregular particles, the shape of the particle. When the particle is more regular, the amount of water required to wet them is less than using irregularly shaped particles. And of course, when the particles are highly porous, so the amount of water required to wet the powder particles and fill all these pores will be more than when you use less porous particles. Okay. Here we are, the methods of manufacturing, or termed calcination process. Okay, each type has its specific method of manufacturing. Okay, number one, plaster of Paris, type 1. It is not called type 1, it is type 2, plaster of Paris or beta hemihydrate or model plaster. This is manufactured by heating the crushed calcium sulfate, the crushed gypsum, which is calcium sulfate dihydrate, in an open vessel, heated at from 110 to 130 degrees centigrade in an open vessel. Okay, not there is no any precautions taken in this process. No, it is a very primitive technique without any precautions, as I said. By this way, we can obtain calcium sulfate hemihydrate plus 1.5 molecule of water. So by heating by this way, 1.5 molecule of water is extracted from the calcium sulfate dihydrate to obtain calcium sulfate hemihydrate, which is type 2 or beta hemihydrate or plaster of Paris. Okay, these powder particles, because of this primitive technique, these particles are irregular and large and porous, highly porous. Okay. Number 2, dental stone, or named type 3 hydrocal or alpha hemihydrate. All these terms should be studied. Okay. We take the same. We take the crushed gypsum, calcium sulfate dihydrate, and heat it to obtain calcium sulfate hemihydrate, which is here the dental stone, plus 1.5 molecule of water. In this situation, it is a kind of special treatment. We heat the crushed gypsum in autoclave at the same temperature. Okay, but it is a kind of special treatment. So the obtained powder particles will be more prismatic, I mean more regular, smaller, and less porous than plaster of Paris powder particles. Okay. Number 3, high strength stone. It is named type 4 improved stone or densite. Okay. Calcium sulfate dihydrate is heated by placing it in boiling water containing an aqueous solution of calcium chloride or magnesium chloride. Okay, by this way we obtain the densite or the high strength stone, calcium sulfate hemihydrate, plus 1.5 molecule of water. Here the technique is more advanced. There is a special treatment, special chemical treatment. They add calcium chloride or magnesium chloride, and both materials are water lovers. They extract water from the calcium sulfate dihydrate. This is special chemical treatment during heating will create powder particles that are the smallest and the most regular and least porous. The setting reaction of gypsum products. When we mix the powder, which is calcium sulfate hemihydrate, with water, calcium sulfate hemihydrate molecule, each calcium sulfate hemihydrate molecule of the mix react with 1.5 molecule of water to give 1 molecule of calcium sulfate dihydrate. This reaction is the reverse of the calcination process. Okay, and this reaction is accompanied by liberation of heat. So it is an exothermic reaction, and the amount of heat liberated during setting of gypsum products equals the amount of heat used in the calcination process. Okay, how could setting occur? This explained by many theories, and the most accepted theory is the crystalline one. Okay, crystalline theory depends on the difference in solubility of hemihydrate and dihydrate in water at room temperature. This will cause setting of the material. How? When you dissolve the hemihydrate in water, it begins to give its constituent ions, calcium and sulfate ions, and these ions will react with each other again and with 2 molecules of water to form calcium sulfate dihydrate molecules. Okay, and the calcium sulfate dihydrate molecules that have been formed begin to dissolve again in water, but the dissolution rate of the calcium sulfate hemihydrate exceeds the dissolution rate of calcium sulfate dihydrate. Okay, so the setting occurs. The solubility of hemihydrate in water at room temperature is 4 times more than the solubility of dihydrate in water. When the hemihydrate is mixed with water, I said some of the hemihydrate begins to dissolve in water and give the constituent ions, which is calcium and sulfate ions, and these ions begin to form the dihydrate in the solution. Okay, and the dihydrate itself the formed dihydrate begins to dissolve, but the solubility of hemihydrate exceeds that of the formed dihydrate. This will result in increasing the concentration of the formed dihydrate, so the solution will be supersaturated with dihydrate. Okay, and the excess dihydrate, because it is supersaturated, this excess dihydrate will start to precipitate and form nuclei of crystallization. Once this nuclei of crystallization is formed, the other dihydrate that form begin to aggregate around this nuclei of crystallization, and the crystal growth occurs until all the hemihydrate is completely converted to dihydrate. There is no hemihydrate residue. All the hemihydrate is converted to dihydrate. At this step, the reaction is completed. Now, what about the amount of water required for setting of the gypsum? By calculations, they found that 100 gram of calcium sulfate hemihydrate, 100 gram of the powder, requires 18.6 milliliter of water in order to convert this amount of calcium sulfate hemihydrate to calcium sulfate dihydrate. So this 18.6 milliliter of water is termed water of crystallization or bonded water, because only this amount of water is required for the setting reaction, for the conversion of the hemihydrate to dihydrate. So it is water of crystallization from its name, or bonded water, because this water bonded to the hemihydrate or the calcium sulfate hemihydrate and form the dihydrate. Okay, but practically this is not the situation, because we require to add we need to add more water to produce homogeneous workable mix. If you add only 18.6 milliliter of water to 100 gram of calcium sulfate hemihydrate, of course the reaction will be completed and all the hemihydrate is converted to dihydrate, but the mix, you will find that the mix is friable. Okay, it is not slurry with sufficient flow so you can pour it easily inside the impression. No, it will be friable. Okay, so I have to add more water, more than the water of crystallization, in order to produce homogeneous workable mix. So the mix that I use can be poured easily inside the impression and flow to record all the details. Okay, this excess amount of water that I need to add to produce homogeneous workable mix is present in the final product, present in the final cast or model, okay, as free water. So at the end of the reaction, the model will contain this excess water as free water, not bonded. Only 18.6 milliliter is bonded water, and the excess that I added to produce homogeneous workable mix is free. So this free water by time evaporate and leave the set material porous. So the cast or the model, you will find that the model is porous. Why? Because this excess water that I add to produce homogeneous workable mix evaporate, and this takes within 7 days. It will evaporate to leave the cast or the model porous structure. Okay, the different types of gypsum products, all the 3 types, require different amount of water to produce homogeneous workable mix. This is because of the difference in particle size, shape and porosity. The model plaster, as we mentioned before, has large irregular particles with which is more porous, and that's all. So it requires more water to wet the surface and to produce homogeneous workable mix. Dental stone require less amount of water, and improved stone required the least amount of water, because the particle size are the particles of improved stone, the particles of improved stone are the smallest, the least porous and the most regular. Okay, the phases of setting. As the reaction proceeds, the material passes in certain phases, and we should use the mix as soon as possible after mixing. If you don't, its viscosity will begin to increase until it reaches a point where the material have high viscosity and cannot be poured inside the impression. It will be unworkable. Okay, so you have to use the mix as soon as possible. You should pour it immediately after mixing. Okay, the setting time of the material is divided into 4 different times. Okay, number 1, the mixing time. The mixing time, it starts from addition of powder to the water until obtaining homogeneous workable mix. This is the mixing time. If you obtain homogeneous workable mix, stop mixing and start pouring the mix inside the impression. And the mixing time in hand mixing is about 1 minute, but for mechanical mixing it is half that time. Okay, The working time is the time available for mixing of the material and pouring it inside the impression. Okay, it takes about 3 minutes from the start of mixing, from the addition of powder to water, until pouring the impression, pouring the mix inside the impression. This takes 3 minutes. Okay. After that, initial setting time. The initial setting time is a time from the start of mixing until partial setting. Okay, how could I observe, or how could I notice that the material in the partial setting stage or in the initial setting stage? This can be practically observed by observing the surface of the mix. At the beginning, after mixing, at the beginning you find that the surface of the mix is glossy. Okay, but by time this glossy surface disappears. The surface becomes dull. Why? It is glossy at the beginning because of the excess water, and the excess water is taken up gradually in forming the dihydrate. So the surface becomes dull. Okay, there is loss of gloss by time. This is a practical indication for initial setting time, practically only, but it is not very accurate. Okay. At this situation, at the initial setting, the material is hard but not strong enough, so you cannot remove the model from the impression. Okay, in the final setting time, the final setting time is reached within several hours. The material is completely set and have sufficient strength and hardness. Okay, it takes several hours. So at which point can you use the material and separate it from the impression, I mean the model? At which point can you separate the model from the impression? It takes 30 minutes. After half an hour you can separate the model from the impression without risk of affecting the model or breaking it. Its compressive strength is sufficient enough. It's about 80% of its total strength, so you can remove it at ease after half an hour. Okay. Measuring the setting time. How could we measure the setting time? Number one, loss of gloss. Loss of gloss, as I told you before, it indicates the initial setting, but this is only practically, not very accurate, because the loss of gloss actually occur 2 minutes earlier than the initial setting. Okay. Number two, the temperature rise. When you feel the model while setting, you will find that, or you will feel that the surface is slightly hot. This is because the reaction is exothermic reaction. Setting reaction of gypsum products is exothermic reaction accompanied by liberation of heat. Okay, this is an indication for setting of the material. Okay. Number three, penetration test. Penetration test is the most or the accurate method used for measuring the setting time, and these tests, we have two types of tests. It will be explained in the lab. Practically and for your exam, it's very important to understand the factors that can control the setting time. Okay, according to the crystalline theory, we have three mechanisms that can achieve controlling the setting time. These mechanisms are solubility of hemihydrate, affecting the solubility of hemihydrate, or the number of nuclei of crystallization, or rate of crystal growth, or all of them. Okay. By say, if the factor increase the solubility of hemihydrate, of course this will lead to increasing the number of nuclei of crystallization, and then increasing the rate of crystal growth, and finally the reaction is accelerated. This means the setting reaction occurs rapidly. The material set faster. This means that the setting time is decreased. So decreasing this setting time or the word acceleration, it is the same meaning. Okay, this can be achieved by increasing all these factors or one of them, so the setting time will be decreased. The factors that can control the setting time are divided into two categories: factors related to the manufacturer, controlled by the manufacturer, and the factors controlled by the operator. The operator, the person who will mix the powder with water, whether the dentist or the technician. Okay, here we are going to discuss the factors controlled by the manufacturer. Okay, number one, fineness of the powder. The manufacturer can grind the powder particles to make it very fine. Okay, so by decreasing the size of the powder particles, so the surface area of the particles exposed to be wetted with water will be more, so the solubility of hemihydrate will increase. Of course, when you have coarse powder particles, say for example when you have coarse particles of sugar and fine particles of sugar, and you start to dissolve same or equal volume of the two different sizes of sugar in water, an equal amount of water, the fine particles will dissolve faster because their size of particles is very small, so its total surface area of all of these particles is more than the surface area of the large particles, so they will dissolve faster because they will be wetted with water faster and will dissolve faster, so increasing the solubility of hemihydrate here in model and die material. By decreasing the size, the surface area increase, so the solubility of the hemihydrate increases, leading to increasing the nuclei of crystallization and increasing the crystal growth, as we mentioned before, the paradigm. Increasing the solubility of hemihydrate will increase the number of nuclei of crystallization and hence affect the rate of crystal growth, increasing it. So it will lead to acceleration of the reaction or decreasing the setting time. Okay. Number two of the factors is the impurities, addition of impurities. The manufacturer can add small amount of set gypsum. It is termed tira alba. Set gypsum means that it is calcium sulfate dihydrate. Dihydrate is added in small amount, only 0.5 to 1%. It is named tira alba. So when you should know the name. Tira alba means small amount of set gypsum. It is dihydrate crystals. Okay. This small amount of set material added to the hemihydrate. So when you mix the powder with water, the powder is already containing small amount of dihydrate crystals. So this dihydrate will act as nuclei of crystallization. So it increases the number of nuclei of crystallization, and therefore the rate of crystal growth will increase and the reaction is accelerated. Number three, the chemicals, and this is the most effective method that the manufacturer use to control the setting time. And we have two different types of accelerators, chemicals, two different types of chemicals, whether accelerators or retarders. The accelerators, the manufacturer used 2% potassium sulfate. Accelerators, most of the soluble inorganic salts can act as accelerators, but the most commonly used one is addition of 2% potassium sulfate. This potassium sulfate, this limited amount of potassium sulfate, act by two ways: increasing the nuclei of crystallization and at the same time increasing the solubility of hemihydrate. so the reaction will be accelerated by these two mechanisms. If the manufacturer add more than 2% of potassium sulfate, this amount of potassium sulfate will not act as accelerator, but it will act as retarder. It will retard the reaction, increase the setting time. Okay, this is because this excess amount of potassium sulfate will deposit or coat the surface of the crystals and prevent its dissolution. Okay, the second type of chemicals is retarders. Retarders act by poisoning, making poisoning effect. How? It acts by forming adsorbed layer on the surface of hemihydrate or the surface of the growing dihydrate crystals. If it is adsorbed on the surface of the hemihydrate, coating the surface of hemihydrate, it will decrease its dissolution. And if it coats the surface of already growing dihydrate crystals, it will inhibit its further growth. So this is called poisoning effect. Okay, the most common retarders are the hydrocolloid impressions that we use, the agar and alginate. We have two types of hydrocolloid impression materials, agar and alginate. If you take an impression with hydrocolloid impression material and pour it directly with a mix of gypsum product, the hydrocolloid impression contain constituents that will inhibit or retard the setting of the model and dye material. Okay, number 2, blood and saliva. Before transferring to this point, when you take an impression with hydrocolloid impression, before pouring it with a gypsum product, you have to immerse it. After washing it with water, you have to immerse it in a solution containing 2% potassium sulfate. This will act as accelerator and accelerate the setting of, counteract the retarding effect of hydrocolloid impression and accelerate the setting of gypsum products. Okay, number 2, the blood and saliva. Effect of blood and saliva on the setting of gypsum. It also retards the setting of gypsum. Of course, it is not a manufacturer mistake, it is an operator's mistake. When you take an impression to your patient, you have to wash it. After taking the impression, you have to wash it with water thoroughly, and then make disinfection to this impression before delivering it to the technician to pour it with model material. Okay, this is an ethical issue. You have to wash the impression and make disinfection. Ethically, for controlling the infection, and at the same time, because existence of blood and saliva on the surface of the impression will retard the setting of the gypsum. Okay, now what are the factors that can be controlled by the operator? The factors that affect setting time and can be controlled by the operator. Number 1, the water powder ratio. I can control the setting time by controlling the water powder ratio. If you increase the water powder ratio by increasing the amount of water, this means that the mix is thin. Okay, this means that the number of nuclei of crystallization per unit volume will be less. Imagine if you have a cup of water containing 100 nuclei of crystallization and half cup of water containing the same number of nuclei of crystallization, 100. Which one will set faster? Of course, the one that contain the 100 nuclei of crystallization in half cup of water by decreasing the amount of water. This will set faster. Here I increase the water powder ratio, so I have a thin mix. So when you make a thin mix, the number of nuclei of crystallization per unit volume will be less. So the number of crystals that grow is less, and the rate of crystal growth is decreased, and finally the reaction is retarded. It will take time, the setting time increase. Okay. Number 2, the mixing time and rate. I told you before that the mixing time in hand mixing is just 1 minute, but in mechanical mixing the time is decreased to 30 seconds. Okay. In mixing time and rate, if you increase the mixing time and rate within the practical limit, within this limit that I told you, if you increase the mixing time and rate, you are already breaking the already formed crystals, dihydrate crystals. You will break it during mixing, so this will increase the number of nuclei of crystallization per unit volume, and of course this will result in acceleration of the reaction because the rate of crystal growth will increase. Okay. Increasing the mixing rate by increasing the number of rotations of your spatula inside the mix. Okay, number of rotation per time. This increase the mixing rate. So again, by increasing mixing time and rate within the practical limit, you will break the already formed dihydrate crystals during mixing, and this will create more nuclei of crystallization per unit volume that will lead to increasing the number of crystals and increasing the crystal growth rate, and finally accelerate the reaction. The setting time is shortened, decreased. The third factor is the temperature of water. The longest setting time is obtained if you use water at 0 degrees centigrade. Of course, we don't use water at 0 degrees centigrade. We use it at room temperature. At room temperature, from the room temperature to up to 50 degrees centigrade, if you increase the temperature from the room temperature up to 50 degrees centigrade, acceleration of the reaction occurs. The setting time is decreased. Why? Because most of the chemical reactions, as you know, within limit, most of the chemical reactions are accelerated by increasing the temperature. So in this situation, the reaction is accelerated. But above 50 degrees centigrade, the reaction is retarded, because increasing the temperature of water above 50 degrees centigrade will lead to increasing the solubility of the hemihydrate, increasing the solubility of dihydrate to approximate the rate of dissolution of the hemihydrate. But it's still hemihydrate dissolution is more. Okay, so retardation reaction will take place. When you increase the temperature or use water in temperature between 80 to 100 degrees centigrade, no reaction will occur, no setting. Okay, because the solubility of hemihydrate and dihydrate at this temperature is equal. The amount of hemihydrate that dissolve equal the amount of dihydrate that dissolve, that form and dissolve. Okay, so no reaction, no setting. Now we are going to explain the properties of gypsum products, including the dimensional changes, their compressive strength, the hardness and the abrasion resistance, and the reproduction of details. Dimensional changes that occur during setting of gypsum products. Theoretically, they found by calculation that the final volume of the dihydrate is less by 7% than the total volume of the reactants, which are hemihydrate and water, used in the mixing, and therefore they suppose that the reaction is accompanied by contraction. But this is not the actual situation. Actually, when the material set undergo expansion due to outward stress or thrusting of growing crystals, the crystals during their growth, they push against each other, push in outward direction, so the expansion occur during setting, and the final structure that will result is interlocking crystals and pores in between these crystals that are filled with water, and this water evaporates by time. Here the model plaster has the most or the highest amount of expansion, and the improved stone shows the least amount of expansion. Also, regarding the porosity, model plaster shows high porosity, percent of porosity is higher compared to the other two types. Why? Because model plaster, during mixing the powder, we use more water during mixing because of the particle size and shape and porosity. They have large particles with irregular shapes and most porous, so it requires more water during mixing. So when this water evaporates by time after setting, it leaves the structure more porous than the other two types. Now you know that expansion of the gypsum products during setting is considered a source of error, so we have to control the setting expansion. In order to control the setting expansion, there are numerous factors. 3 factors can control the setting expansion. To decrease the setting expansion, you can change the water powder ratio, change the mixing time and rate, or adding chemicals. The water powder ratio, if you increase the water powder ratio using thin mix, so the number of nuclei of crystallization per unit volume, as we mentioned before, will be decreased because we use a thin mix. The amount of water is more. So this will result in that the crystals are spaced from each other. There is more spaces between these crystals, so the thrusting action is decreased. They are not close to each other to thrust against each other, to push against each other. Okay, they are spaced, so the outward thrusting is decreased, and of course the setting expansion is decreased. The mixing time and rate, if you decrease the mixing time and rate, so the number of nuclei of crystallization per unit volume also decrease, and the spaces between the growing crystals increase, resulting in decreasing the thrusting and decreasing the setting expansion. For sure, we cannot control the setting expansion by making thin mix or changing the mixing time and rate, because this will affect other properties. But the most effective way to control the setting expansion is addition of chemicals. Adding 2% potassium sulfate, it acts by regulating the shape of the crystals, so decreasing the thrusting action of these crystals. Of course, if these crystals are more regular in shape, their thrusting against each other will be less than if these crystals are irregular. Hygroscopic expansion is a special type of expansion that occurs in gypsum when it is allowed to set underwater, specifically or definitely during the initial stage of setting, while the crystals are still growing. Okay, when you take the model and during setting and immerse it in water, okay, hygroscopic expansion can occur. There is a specific situation or condition required for occurrence of the hygroscopic expansion, which is that this process occurs during the initial stage of setting only, because the crystals at this stage are still growing. So when you provide it with more water, this water will provide more room for these crystals to grow through and thrust against each other. The hygroscopic expansion is double or more than double the normal setting expansion. In the normal setting expansion, you find that as this observed in the photograph, in the diagram, that the crystal growth is limited by limited amount of water, that its surface tension, the surface tension of this water, of this limited amount of water, limits the growth of these crystals and inhibit it from developing more expansion, as in the hygroscopic expansion. The compressive strength of gypsum products develop gradually by time. We have two types of strength: wet strength and dry strength. The wet strength is named green or 1 hour strength. It is the strength of the set gypsum while it is still containing the excess water. After 1 hour, it is still containing the excess water. So it's named 1 hour strength or wet strength or green strength. Green strength related to something you observe in nature, that when you plant a tree, at the beginning the stem, while the tree is still young, the stem of this tree is green, okay, and by time, while this tree is growing, by time the stem of this tree is converted from the green color to the brown color and become stronger and stronger. So the name comes from this fact, okay, the green strength. Dry strength, after 7 days, during this time the excess water evaporate gradually, and due to evaporation or loss of this excess water, by time after 7 days all this excess water is evaporated, resulting in increasing the strength of the material. It's called dry strength or 7 days strength. The dry strength, of course, is more than the wet strength. It is double the wet strength, but it is not essential to the cause why the dry strength is more. Now, what are the factors that affect the strength of gypsum products? Number one, the water powder ratio. If we increase the water powder ratio, means using thin mix, so there is excess water that will evaporate, leaving pores inside the cast or the model. So the strength of that model is decreased, okay, because any porous structure is weaker than non-porous one, of course, or less porous one. So if you increase the amount of porosity in the model, this will affect the strength and decrease it, okay. This is done if you increase the amount of water. Number two, the mixing time and rate. Increasing the mixing time and rate within limits, this will increase the nuclei of crystallization per unit volume, as we mentioned before, because you break the recently formed nuclei of crystallization, recently formed dihydrate crystals. So increasing the nuclei of crystallization per unit volume, that will increase the growing crystals per unit volume and increase the crystalline interlocking. When you increase the number of growing crystals per unit volume, these crystals will interlock with each other during their growth, and their interlocking is more. So when the structure have interlocked crystals, this means that the strength will be higher. Of course, overmixing, you break the formed large dihydrate crystals, and this have a detrimental effect on the strength, because you break these large dihydrate crystals and there is no crystalline interlocking, and the amount of interlocking is decreased, so the strength will decrease. This is by overmixing, okay. Number three, the chemicals. Using chemicals like potassium sulfate regulate the shape of the crystals, as we mentioned before, but in this situation, relation of the shape of the crystals and its effect on the strength, it decreases the interlocking or the cohesion between the crystals, okay, because these crystals are more regular, so the amount of interlocking is decreased, so the strength, of course, will decrease. Number four, the type of gypsum product. We all know that the strength of the improved stone is the highest among the other two types, because it requires least amount of water to produce homogeneous workable mix. When it evaporates after setting, it leaves the structure or the model having less porosity, okay, but the strength of the improved stone can be decreased, and its strength will be comparable to that of model plaster if you use excess water. If you add excess water during mixing, this will decrease the strength of the improved stone. Okay, number 5, the dryness. I have just told you that the dry strength is more than the wet strength. Strength after 7 days is more than the strength after 1 hour. Okay, addition of wetting agent. The last factor, addition of wetting agent, like lignosulfate. The manufacturer add lignosulfate as a wetting agent inside the powder. So when you use the powder, there is no need to increase the amount of water. We can use less amount of water, so there is less excess water in the final product and less porosity, resulting in improving the strength of the model. Okay, the last 2 properties that we need to talk about is the hardness and abrasion resistance. One of them is the hardness and abrasion resistance. You know that the hardness of this material is low, can be easily scratched. Okay, and we can improve this property by impregnating the set material inside a resin like methyl methacrylate monomer, and then allowing this monomer to polymerize. This will improve the hardness. Okay, another way to improve the hardness by creating an electroplated dies. Okay, the last property is reproduction of details. Actually, the gypsum products are not very accurate because the surface of this material is always porous. When you observe it under microscope, you will find that the surface is porous. Of course, this is because of the excess water that evaporate by time. Another reason, air bubbles can be entrapped at the interface with certain impression materials, like certain silicone impression materials. Okay, these air bubbles that is entrapped is due to the poor wettability of the impression of these types of impression by the gypsum products. Okay, this is the last property that that's mentioned, and thank you.